Hello, good morning. How are you? How have you been? This is Thacienne. I'm here again. Today I'm going to talk about a topic which is dedicated to you, whether you are a data scientist or you are a data analyst or you are interested in data analytics. In today's presentation, I'll be talking about how we can visualize a data set in base R, not in ggplot2, in base R, because we can't understand the ggplot2 if we don't understand the base R functionalities. So I will go step by step and I will show you how you can create your own graphs in R, in base R. I will be talking about the four useful functions, most useful function used in making graphs in R. This is the curve function, the plot function, the hist function, and the box plot function. Let's go together step by step and see how we can make these functions useful for us and for others to see our visualization. I hope you're going to enjoy today's presentation. If you like the video, click like and share the video to your network. And hey, if it's your first time to be on this channel, please don't forget to subscribe and turn on the notification bell so that you will get notified anytime we upload a video. So please watch from the start to the end. Let's go. Let's start with the function curve. Suppose that we have this function y equal to x squared and we want to visualize it in the range from 0 to 1. And I want that we visualize this function using two functions. First we use the function curve and next we use the function plot and see the difference between those two functions. With the function curve, it is just simple and easy. You just type curve, and you write your function. The function is x power 2. And then you specify the range. It's from, you write from when, from where, from 0. And to which number? To 1. Simple. If I click enter, I get my plot here. Then let me make it bigger so that you can see it well. Here I go. This is our plot. We have x values varying from this number 0 to 1. And then we have the x squared. Okay, this is the graph. Easy, very easy. And what if we want to use the function plot? In the case of the function plot, we will need to specify which values of x we have and then the y. And so suppose that, let me write it here. Suppose that we want to visualize the same data, but we want to use the function plot. Now we will need to specify the range of x. We need to specify our values of x. So let's define x. Then x will be equal to a sequence of numbers between 0 and 1. Between 0 and 1. And you have to specify, we can, let me say that we have 0, 0.01, 0.02, 0.03 up to 1. Then I'm adding each step I'm adding 0.01. Then I specify it is specified by this by. If I say by equals 0.01, it means that I will be adding 0.01 to each number. Let me display x or something wrong. This is point, not comma here. This is point, not comma. Yes, now I have my x here. If I display x, you see it here. I have 0, 0.01, 0.02, 0.03 up to 1. And then my y will be equal to x power 2. here. I have y here. Then this is the values of y. Then now I can plot the two variables x and y, because the plot function needs the x and y coordinates. It needs the values for x and the values for y. And I need to specify the type of graph that I need. Let's say that I want to have the same graph as before with a line on a line graph. Then I have to specify the type. Then in this case I need the type to be the line, and then if I need the type to be line, I put L there. If I click enter, I get the plot here, and the same plot. If I zoom it here, you can see it. So you see now I have x and y, and the graph is here, as you can see it. And by default, if you don't specify, let me clean all these graphs so that we not be confused. If you don't specify the type, here is type. If you don't specify it, by default, it will be a graph of points. Points. It means it will be displaying its point 0 by 0, 0.001, and 0, yeah. So let me show it how it will look like if I ignore the type. Then it will use the default type, which is points. Then if I click enter, so you see the graph that we get. Let me zoom it. Yeah. So it's a graph but with points. So the default graphics is the points, but you can change, of course, the points. For instance, in the previous graph we have used the L to have L graph here in here, to have line graph here. Yeah, there is many way to change this type. You can use S. If I use S here, what will I get? I get a plot of this form. Yeah, here. So you see, there is many way. If you just Google it, you will find a way of adjusting this type in plot the way you want it to look like. You can use, for instance, B here. B. If I use B here, so you see I get a plot like this, almost the same as B. So yeah, there is different ways, but the most important thing is this X and Y, and then you can specify the type of the graph you want it to look like as you want. Yeah, isn't it easy? It is very, very, very easy. Let's move on. Yeah, the other function that is used in creating plots in base R is the history. And guys, there is one video that I made. I showed you how to make histograms in R. The video link is pinned on this in the comment down here. If you want to learn much about how to make histograms with the function hist, I recommend you to watch that video, because it was made specifically for the hist function and the histograms. But just to make it quick, a quick reminder, I can just make one plot with hist function, but please go also to that video and watch it. But let's also use it here for those who didn't have time to watch the video, or who don't have time to go now and watch the video. Let me clean these things so that we get a space to work on. I also clean these graphs, we don't need them anymore. And we're going to work with the function history. This time, do you remember, guys, the iris data set? In our previous video, we used it. In our video, the iris data set. Iris data set. Do you remember it? It's a built-in data set in R. Pop up already here. If I click iris here, and let me use here iris so that we can remind ourselves what it is. We saw that it's a data set with 150 observations and 5 variables, and those variables is the sepal length and the sepal width, the petal length and the petal width, and the spaces. And the spaces are 3 spaces, because we have here 3 levels. The setosa versicolor, and the other one, don't remember, let me type levels. Levels iris, iris, and spaces. If I click enter, so you see we have the levels, we have the setosa and the versicolor and the virginica. We have 3 spaces. So let me use again this data set to show you how to make a quick one, just to show you how to make useful the histogram. Suppose that I want to visualize this petal length for the setosa space. Is it space? Space, yes. How can we do it? It's just the first thing that we have to do is the function hist. But what the hist will take, it needs the data. Which data set we need? We need the data set from iris, but which data set? It's the data set for the space called setosa. Yeah, we need the setosa. Then iris setosa, iris space, or iris space equals setosa. Is it setosa? Yo, setosa, yes. And it's all we need only the rows of setosas and for all the columns, but we only need the petal length. Then I specify what we need from there. We need the petal length. Is it written very well? Make sure that you type it the way it is typed there. Petal dot length. Petal dot length. Yes, petal dot length. If I close this like this and I make hist like this, that there's something wrong. Unexpected parentheses. Oh yeah, here. Yeah, something wrong there, of course, because this parenthesis is not in the right way. Yes, the parenthesis here. Then I get my histogram there. I zoom it here so that you can see it where we have our histogram here. But hey, there is other things that we can add to this histogram, and I don't want to talk about it here because as I have been told you, I made a video about histograms. Then please watch the video. I have pinned the video link in the comment. Watch the video and we will see how we can change the colors of these bars. We can see how to add the title, how to change this the x-axis title, how to change the y-axis title. Yes, everything. So please make sure to watch that video. But in a simple way, it's the functionality of hist, it's just like that. Yeah. Yes, so let's continue working with this iris dataset, and then now I'm going to show you how to use the function box plot. Suppose that we want to make a box plot to visualize this petal width for the vertical color space, the box plot. So how do we do it? Let me clean this. I clean this so that we have a space to work. And how do we do it? You just type box plot. Box plot. What do I want to plot? I've said that it's the petal white. Is it petal white or rosette white? Whatever. Then it's the iris dataset, and in the iris dataset, I wanted the iris space to be iris spaces. It's like this. Spaces to be equals to color onko. Is it color? Yes, color, and all the rows with that space and all the columns, but for the sepal width, and I want this box plot. Yes, then if I click enter like this, I get the box plot here. So you see, I zoom it so that you can see how it looks like. This is the box plot. And we can also change the color of that box plot as it is done for the plot or the hist function. I've told you to go to the function to see how to change those things, but let me show you at least here for the box plot, because the first time to use the box plot in my videos. Then you just type color here, color equal, you can specify the color that you want. Let me suppose that I want to make it blue. Then if I click blue there, then enter, the plot change to blue. Let me zoom it, you can see it. I don't know if like that you can see it, but if I zoom it here, you can see it clear that the color has changed into the blue color. Yeah, I hope you know how to read the box plot. This is the mean value. Yeah, and things are very easy. Making the box plot is just simple like that. Yeah, very easy. Now suppose that we want to make a grouped box plot for all the spaces. We are using also this sepal white, and now not only for the vertical space, but for all the spaces. Let's say that we want a grouped box plot for all the spaces. How do we do it? We just write box plot, but in this case we specify what box plot we want to make for which variable. The variable that we need is the iris sepal width, and then we use the tilde sign. The tilde sign, this sign, the tilde, and we specify which groups we want. Then the group is the iris spaces. We want the iris spaces to be the groups we want to make graphs of the box plot for each of those groups, for the sepal width for each of those groups. Then the iris spaces like this. And we can specify the colors. As we have seen that these iris spaces has 3 levels. It has 3 different spaces. Then when you specify the color, it will be now a vector of 3 different colors. And let me say, then you specify the color for each space. Let me say that the first will be, let's say, red. And the next one, let's say that will be blue, and then the other space, let me say that it may be green. Then like this, I will get, this will result into 3 different box plots, for one for each space. One red, the other one green, and the other one blue. Let me hit enter so that we can see how the verses. Yeah, it looks like this. Let me zoom it for you to see it clearly. Yeah. So you see, we have our box plots. The red one for setosa spaces, and of course we have the iris sepoide, the sepoide for the setosa, sepoide for the versicolor, and the sepoide for the virginicolor. So you see, it's very just easy like that, and you get your box plot easy to read. And if you want, you can add the titles, but I will show you down in the next examples how to add the graphics here, like the title, the subtitles, everything. So then keep watching. We are still moving. Yeah. Yeah, so let's move on. The other type of graphs that is most used in data visualization is the scatter plot. Suppose that we need to know the relationship between the petal length and the petal width in this iris data set. And then in this case, we'll use the scatter plot. To make a scatter plot, we use the plot function. Then plot. And what do we want to plot? We want to plot the iris petal length, and then followed by the tilde sign, and then the iris petal width, like this. Yeah, and you can specify. You can specify the X labels, then X labels to be petal length, and you can specify also the Y labels. Y label equals, in this case, the petal width, like this. And if I hit enter, yes, I get my graph, my scatter plot there. I zoom it so that you can see it again. Then it looks like this. And we can add colors based on the spaces, because in this plot we have, yes, the petal length and the petal width, but remember that we have different spaces. So suppose that we want to like identify in this plot, we want to identify the spaces by adding the colors corresponding to that spaces. So then we have to define a vector of colors. Let me say colors equal, then in this case it will be a vector of 3 colors. Let's use the same colors as we have used above. Then red, the red color, and the other one blue, and then the other one green, green like this. Then we have to, of course, put the guillaumes in here, because it should be a character, green, like this. Yes, unexpected. We have here, I have equal, and yeah, of course I have to clean one of these. Yes, like this, the colors. And since I have defined the colors, then I can now add the colors to our plot. We have this plot, and then we can add the colors with the core graphic, then call equal, in this case colors of iris spaces, iris and spaces. What does this do? What does it do? We have this function, we have this vector of colors, this vector of colors, the red, the blue and the green. Then it takes the values in the iris spaces. It means those three levels, the setosa, the versicolor and the virginica. Then it will be assigning to each either red or blue or green, depending on the row on which row we are. If the petal length and the petal width that we have correspond to the setosa, it will assign red. If they correspond to the versicolor, it will assign the blue one, and then for the virginica it will assign the green one. That's why I have used these iris spaces, because the iris space is the column for the levels, for the spaces. Then if I hit enter like this, so you see the graph change. Let me zoom it so that you can see it. Down here, so you see it changed. Then it showed this one in red. This is the data for the setosa, and this the green one for the blue one, sorry, for the versicolor, and the green one for the virginica. So you see, very useful. And if you want, you can add legend to this graph. How do we add the legend? So that everyone who can read this one will know which one is for the setosa, which one is for the versicolor, which one is for the virginica. Let's suppose that we want our legend to be here on the top left corner of our graphs. You can also put it here on the bottom right, but let's put it here at the upper corner, this left corner of our graph. How do we do it? Let me close this one. So we use the function legend, and then we specify where our legend is located. In this case, the top left corner, and then legend equal, and then we specify which legend you want to use. In this case, we need the levels of our iris spaces. Then levels, iris spaces. It will be the setosa, the versicolor, and the virginica one. Then you specify the colors. The graphic color should be the same colors that we have in our graph. Then in this case, the red, blue, and green. Then the colors should be this vector color. Then I specify color. Let me write it well. Colors like this. Yes, if I hit enter like this, I get my graph here. But you also have to specify the pitches, what the PCH, let me say equal to 1, for instance. Then because we have the points there, if I hit enter, they are here, you get setosa red and the versicolor blue and virginica green. But again, let me zoom it here. I zoom it like this. But you see, our legend box is overlapping our graph, and we don't want it to look like this. This is so bad. It's not readable. To resize this box, we use the function sex. This is the function of the graphics, the graphics 6. Then you add here 6, here 6 equal, then let's say 0.5 like this. Here 6 it's point, not comma. Please, you have to be careful. Point, not comma. Point. Yes, like this. So you see the graph change. Let me zoom it like this. So you see, let me clean it so that you can see it well, because this is overlapping the first one. Let me clean this, and then I hit this, and then add this legend like this. Here you go, and we get the graph which looks like this. So does this looks better now? Yes, it looks better. Everybody who read this one will see that the setosa is these ones, and the versicolor, the blue ones, and the virginica, the green one. Useful and wonderful. Yeah. So guys, I hope we have now at least a basic introduction of how to make a graph in RBase. But let me say this, there is some parameters that we need to know, and we need to know how to use them. And I think I have to make another video, the next video to this one. And I want to close today this presentation here, but let me say this, we need to understand these parameters when we are making a graph, and especially when we are using the function plot, and those parameters is the main, the parameter which is used to add the title to our graphics, and the other one is the X lab and Y lab, the ones which are used to put titles on X-axis and title on Y-axis, and the other parameter is the sub, the one which is used to add a subtitle, and the other parameter is the other one, of course, the legend, and we have seen how to add the legend. Yes, and the other one is the call to add the colors, and the other one is the pitch to size the size of your, if it's a point, how much, what is the size of your point, if the line, which size it will have, the pitch, PCH, and the sex for the graphics. And we also need to know how to arrange graphs. We may need a graph with different graphs but in one figure. How do we do it? We also need to know that one. Or we also need to know how to add graphics to an existing plot. For instance, if I have this plot and I want to add a line, how do we do it? Just like that. And guys, I want you to watch the other video that I will upload after this one, because I will tackle all those things. And the video will be very interesting than this one. Yeah, because this is the best one, but we need to understand each and every function and how to use it. So then I hope you will also watch that video so that you know all those parameters and how to use them. I hope you have enjoyed today's video, and I hope to see you next time. And I hope you will see you will watch the following video to this one to understand better. If you like the video, click like, and remember to share the video to your network. Bye.